Welcome everyone that's on the webinar. And with me, I have Anna Walter, one of our senior business analysts here at ClickData. And, just to let her get through the good stuff, just want to make sure that everybody can see and hear us properly. We are recording this webinar as always, and it will be posted on our YouTube channel as well as on our website. It is a moderated chat, and you will be able to ask your questions, and we'll be able to answer them either throughout the presentation or the webinar or at the end. And you can also, of course, follow us and react on Twitter. So with that said, and having all green lights on my side as to the audio and video piece, I will get started. Just so you know that these webinars are really important to us. It is one of the many channels we have to get feedback. So please do ask our questions. If we do not answer them though, don't worry, we will keep them and we'll try to get to them either directly via email or by phone. So without further ado, let's just talk a bit about what ClickData is. If you are new to ClickData, we are a full end-to-end data and BI platform. We have basically a lot of connectors that allow you to connect to different data sources and pull that data into your own data warehouse. And with that, once the data is there, you can do all types of cleansing of the data, treatment of the data, calculations, what we call data management here. And then you can serve that via dashboards and soon via reports using our data visualization module. Finally, these dashboards and these reports can be shared, as well as the data can be shared to collaborators, teams, employees, partners, clients, etc. And also, you can do some your own if you have a dedicated subscription. You can do some advanced analytics and intelligence, whether you're using Python or other external tools to go directly against the database and produce some statistics based out of that. So we're basically all these different tools into one tool, all cloud, all available to you. And we'd like to think that because of that, and not only because of that, but because we have an entire understanding of the data from the beginning to the end, that we have much faster implementations, and that you can reproduce your reports and dashboards much faster, and that saves you time and money, and that gives you more revenue, or at least lowers your costs. So that is the entire BI platform and ClickData as a whole. This very complex diagram, as you can see here, it's kind of our vision of what ClickData has to offer to you. So there's a lot of things here, some technical, some not so technical. But whereas other tools just offer little pieces of this and that, visualization or this, we actually try to offer the whole thing the best way we can and the more intelligent way we can. And there's some great new modules coming up soon, reports, insights, and live docs. And we'll talk potentially about data flows as well very, very soon. So with that, it is important that you understand that we are fully cloud-based. There's no on-premise, that we host the data in a variety of data centers in Europe and the US, and then we have dedicated data centers around the world. That basically we have a very strong backup and security data policy, so your data is secured. We host all our data with Microsoft Azure, which gives us a lot of flexibility in terms of where we can have the data, but the level of security that we offer as well in providing that data to you. And all this so that you can have all kinds of different types of dashboards. Our dashboard is really a canvas for basically your data analytics imagination, if you will. We have not only visualization, things that output data to or information to the user, but also a lot of other things such as input widgets and recently data form where you can collect data. So it becomes really a nice ecosystem for you to develop and to expand on just this notion of what a dashboard can be and what it can do. And with the new report modules, we really complete as well that entire visualization piece where we still have multi-page PDFs reports in today's day and age. And with that, I stop my pitch about ClickData and about who we are. And I'd like to pass it over to Anna. Anna Walter, over to you.
Thanks, Telmo. I hope everyone can hear me. Hello, everyone. So today we're going to talk about one of the features of Click Data, which is not used by everyone, but I think it really deserves some better visibility for everyone. So that's why we actually came up with this theme. We're going to look at the cache feature today. So this is the agenda. So we're first looking at what is cache exactly, what does it do, and then how do we set it up? When do we need it? That's actually a question that comes up very often. And then we're going to look at some examples, some use cases, and resolutions of cache issues actually that we resolved with the team. Okay, so let's go into the first section. What is cache? So basically in Click Data, you can load your data, which we call data sources. That's the raw data you're working with. But then you can create other types of data sets based on those sources. So you have views, you have fusions, and you have merges. So in the views, you can do transformations like calculated columns, filters, aggregations, and that kind of added value to your sources. In the fusions, you can append different data sets together. And with the mergers, you can join data sets together. So with these three types of data sets, you actually create a whole new set of data, which seems to be actually new data sets, but actually they're all very virtual until you cache them. So that means that every time you create a view, you create a virtual data set actually. And this is calculated on the fly each time it is queried, for example, in a dependent view or in a fusion, or if that view is used in a dashboard and widgets, every time the widget is queried, the view will calculate actually based on the query that was done. So these are actually just really visual representation of SQL queries, these view, fusion, and merges. So the difference with the cached version of these datasets is that every time you cache one of them, you actually write and you create a table in the database for them. The table is then calculating the output of the view, the merge of the fusion, and it is set in stone, so to say, in a table on the database. So what does it mean exactly? What difference does it make? If we look at this example here, we have a dashboard using an uncached view. We have 4 users checking that dashboard out at the same time. And each of these widgets will actually be built in your browser, in the browser of the 4 users, by querying the uncached view. So that means that for every query, we actually calculate what is actually done in the view, if there are transformations and filters, etc. So that means that for every widget, we can actually potentially create a new query for one of those underlying data sources. So that means that can actually go into heavy calculations if you have a lot of users looking at the dashboard with a lot of widgets using a lot of different sources. So what happens when you use the same diagram with a cached view? You still have your 4 users looking at the dashboard, you still have the same dashboard, and you still have 4 queries going to the view. In this case, though, the cache is actually applied to the view, so that means that it's already calculated. So there's no calculation done in this case, and that means that typically your widgets will load much faster. And also the system will have less calculations to do, obviously. So how does it work exactly? Let's pick our dashboard again, and let's see how that works. Say we use this view here, the version 23 of that view, in the dashboards. So a cache refresh task is started on this version here, and we actually want to update this version with something, maybe a new transformation on the view. And this actually triggers the cache building for the version 24, which is the next version. So while this one is building, this version here is building, the dashboard still relies on version 23. And it will only switch to the next version, to the version 24, once the cache building is done. And then when the 24th version is available, the version 23 will be trashed. So your dashboard will always show something. Even if you're using cache, it will always show the latest available cache version. Okay, so what are the benefits of caching data? So we talked about performances already. Again, just want to emphasize that cache data is actually pre-calculated, so it's loading faster. In this example here, we can see a view which is timing out. Many of you may have seen these errors before. So this is happening here because this view is based on another view, which is not cached and which is very heavy with a lot of transformations and which are timing out in the end. And here we're actually applying one more transformation, which is again taking a lot of power out of the system. And in the end, it's timing out. So in this case, for example, we can see that it could be interesting to use some caching here on the previous data sets. So we're going to look at these examples in the next slides. But really, the first benefit of caching data is performance, because your data will load faster. And hence, the result is that with cached data, your dashboard will load faster as well. Here on the left, I have the same dashboard than on the right, but on the left, I'm using an uncached version of my data. And when I loaded it, it took maybe 30 seconds to load. Some of the widgets were in error, some not, but it was very long to load. With the cached version, this dashboard actually loaded in 5 seconds, even though the dataset behind it, it's very heavy. Actually, it's 14 million rows. So this is actually something that you can see immediately when you're using cache on slow widgets or timing out widgets. You will see an enhancement of your performances right away. Another benefit of caching data is that you have versioning on the data. So meaning that every time you actually have a cache update happening, this is actually a task in the system. So you can always go to the task logs to actually understand what was happening and what actually what size your data has, how many rows were copied from each version to the next. In this case here, for example, we can see at this example that we're caching this view here, which is called Events All for Music view, and it has almost 14 million rows, and it took 1 hour to cache. Pretty long. So what does it mean? So there are a few things to know about caching data. So first of all, it actually consumes storage. Because remember, we said that an uncached data set is actually a virtual data set. We actually count 10 megabytes by default for an uncached view, merge, or fusion. In reality, though, when you cache it, the table that it actually creates might be much heavier. And in this case here, we have this data set, which is very heavy. You can see it's 310 megabytes. You can, by the way, see here that this data set was cached, this view was cached. We have this little icon here, which is green, and which we will see as well in the next slide. And when it's uncached, you can see it's white. So these are the 4 stages of cache stages. So you can see that when something is green, it means that your cache is ready and up to date. You will see these stages in your data explorer. For example, here we can see how it looks when you actually hover over that little icon here. You can have information on the last build, at which time it was actually built, and if it's up to date or not. So the last thing to know about caching data, so first of all, we said it actually counts in the storage of your account. The other thing is to know is actually it counts as well in refreshes. So why is that so? Every time you have a source refreshing on your on-click data, it costs a refresh, right? So it's the same for a cache data set because it's a table in the database. So basically the table is updated and that is a refresh as well. So you can follow your refreshes amongst your on your whole account in your admin settings section, and you can see how much data refreshes were consumed every month. This is the kind of graph you will get. Okay, how do we set it up? Now we know what cache is, maybe we want to play around with it. So the cache feature can be activated only on views, merges, and fusions. It doesn't make sense on any data source per se, because the data is already a table in the database. So if you go to the properties of a data set, you go to the first tab here, properties, and then here you have this cache tab here at the bottom, and you can choose your caching mode. We'll see in the next slides what each mode does. For now, here you can see this one is not activated, and this is the default status. So the first caching method is the automatic caching. It means that every time a source of that data set will update, the cache of this data set will update as well. So that means that it can be the immediate parent of that data set, or it could be, like two data sets before, like the grandparent. Every time one of the sources in the whole flow of data is updating, the cache will automatically be updated as well. So you just need to set it to automatic, and then you can just build it now right away, or you can save it. This will trigger the creation of the first cache as well. So the other option is the manual option. If you choose the manual caching, that means that obviously you need to trigger it manually, so you can do that on the same screen as we've seen before. Or you can also do that with a task in a schedule using the cache data task. If you want to trigger the manual updating via a schedule, so you need to actually put it to manual. You can't have automatic refresh and manual refresh at the same time. So that would be the right way to go. And we'll see at the end of the presentation an example of when to use automatic versus when to use manual. Okay, and last thing about cache tasks is that you can actually check them out in the Task Explorer. You have access to that in the schedules, in the automation workspace, sorry, where you also have the schedules and the alerts. You have the tasks list there, so you can always go in and have a look at all the tasks that are happening. You also have the data cache tasks like this one. For example, here you can see this one is running. And if you open the task log from here, you will see the detail that we've seen before on one of the previous slides. The same thing that you can also see on the task logs of the properties of a data set. So that's the screen you see here. You can see here each version of your task, and for each of them, you can actually have a look at the logs. So when do I actually need cache? So most of the time you won't need it. You will need it in one of the following cases. Let's say that you are on a dashboard, working on a dashboard, a widget times out. Not always, but sometimes. Or maybe it times out all the time. Or maybe it just takes a very, very long time to load. In that case, it might be interesting to look into the dependencies of that widget and to see if it would make sense to actually cache the view or the merge or the fusion you're using in that widget. So to do that, the best option is actually to do some retro engineering, meaning you open your widgets, and in the editor of your widgets, you have here the data source of the widget. And if you go to that little cog icon, you can actually go to the edit button, and this will automatically open your view, in this case, in a new tab, and you can then explore the view directly and see why it's timing out or why it's slow, etc. Another option is to go from your dashboard. Actually, on the left side, you have this bar here where you have access to widgets, etc. You also have access to all the data sources used in your dashboard. So if you click on that icon, you will see the list of all the data sets of your dashboard. And from here, you can open a view directly as well, or another type of data set. So the other time where you would actually need cache is when you have that type of view which is timing out. That's the case we saw before already. In this case, we have a view which is based on another view. So here we can see that at first it loads well, but then you can see that this tiny transformation here actually times out. So it would make sense to maybe cache the previous view to pre-calculate whatever was done in the previous step. And this will actually probably resolve the issue here. So the last way to explore dependencies when you're working on a view, if you go to the properties of that view, or that also makes sense for mergers or fusions. If you go to the usage tab of the properties, you can see actually the source data and the dependencies. So you can see here, for example, we have opened the source data. So it's by clicking on this little arrow here, we can see all the sources that actually are used with this view. In this case, obviously, there's just one source. But for example, if you're looking at that with from a merge, you can see all the different data sets or sources that are actually flowing into that merge. And if you click on that other little arrow, you will see the dependence. So where this data set is used in another view, in a dashboard, in schedules, etc. So this helps you actually explore the dependencies between data sets and understand where a timeout can come from. Okay, so let's look now at a few examples. Every example is actually unique. If you have not a clear idea of when to use cache, then please don't hesitate, reach out to our support team. We can help you figure it out. So here we have a first example, which is a simple flow with multiple cache datasets. So one of our customers came to us saying, I don't understand. This is taking a long time to update. Every time I update one of my sources, my last view always takes ages to be up to date. So what we can see here, we have 3 data sources flowing into one fusion, which is cache. So that little icon here shows that there is a cache, an automatic cache. This is then used in a view where some transformations were made. And it's also flowing into another view, which actually aggregates back from that secondary view here. And then these views, this last view also goes into an extra view, which is then used in a dashboard. So in this case, we had actually cache on all these steps, which is not a very good practice because you don't need that much cache. In this case here, it means that every time one of the sources here will update, each of these cache will update as well. And probably this time will update twice. First time when this one updates, and then the second time when this one updates. So that's a lot of cache updates, and that's not really interesting in terms of performances, and also not in terms of refreshes. Okay, so let's have a look at the resolution of this one. So in this case, we figured out that actually the view here was struggling a lot to aggregate data from this one, because this one was if I remember correctly, it was actually deduplicating data on a lot of rows, of million of rows. So this one actually was a heavy transformation, and then doing that aggregation back into this view took a long time. So by putting cache only on that step here, it actually resolved the timeout on this view here. And the next view was actually working fine without any delays or whatever. So just simply adding that cache on that specific node resolved the issue. And the other thing that we can mention here is that the fusion most often doesn't really need caching because it's not a very heavy transformation anyways. So it's really just appending data together. So there's not much of calculations going on here. So it's rare that you actually need to cache a fusion. It can happen, of course, but well, most of the time you won't need it. You will mostly need it on views, on merges. Okay, let's have a look at another example. So this one is a bit more complex. We have multiple nodes. So we have 3 sources. 2 of them are going into views, which are then fused together. And then this is put into a merge with another view. And then we have merge and view, and etc. So here we can see that these data sets with the TO flag here, they were timing out. So the question was, okay, where do we put the cache here? There was no cache at all on any of these data sets. So the best idea is actually to do some retro engineering. For example, we can imagine that this view was used in a dashboard which was actually timing out. So by going back to this view, we could see that this merge was actually also timing out. And this view here, which was the parent, was also timing out, and this merge as well. So this one, though, was not timing out. So it means that this view might be pretty straightforward. And the merge here could actually time out because of that fusion or maybe because of that view. But because the fusion here was also timing out, we figured that actually it was this view here, which was doing some complicated calculations that was actually in need for caching so that the calculations would be preloaded and pre-written. And that actually resolved the timeout on the fusion, which in turn resolved the timeout on the merge. This view, though, would still time out as well. But now knowing that this merge here was actually okay, just trying to put the cache over here resolved the next timeout. So you need to try a bit. It's a try and error process with the cache. Most of the times, it's true that it works just to cache the previous step. Sometimes it's a bit more complicated, like we can see in this case here. Okay, and then the last example here. So we have an automatic versus manual case here. So we have these 4 data sources, which are updated via a schedule that runs them in sequence. So I'm sorry here, this is a bit cut off, but definitely we have a merge here and a view here and another merge here, but that doesn't really matter. What is important is the time when the cache was built. So we can see that the first data sources were loaded very quickly. And once they were loaded, the cache here would update at 1 a.m. and 10 minutes. And this would then flow into this view, which would update at 1:11. In the meantime, though, these 3 data sources would flow into this merge, which would update just at 1:13. So that means that this cache here was ready just even before this one was finished, meaning that the cache here would update actually at 1:12. And then later, when this flow here would update as well at 1:20. So meaning that this cache would update multiple times, even though it was actually coming from the same data sources, and that wasn't really necessary. So the solution we came up with in this case, so yeah, just to know, each of these transformations were very heavy, dealing with very big data sets. So the cache was needed everywhere in this case, just to make sure that you could actually even work on those views, because otherwise they would just time out all the time. So the solution here was actually to set up the automatic cache on these 2 processes, because that's the most logical way to do it. But then the manual cache would be put on this one, and at a much later time, to avoid to have the cache here building twice, once the first flow is finished and then once the second flow is finished. So in that case, it would make sense to have the manual cache. And as you can see, we actually put it to cache at a very later time. So to make sure that these different processes were finished. And because it was in the middle of the night, that wouldn't really hurt in any way the reporting, because people wouldn't look at the reports at 3 a.m. anyways. Okay, so that was for me today. I hope you enjoyed that presentation. If you have questions, please feel free to ask
Actually,
them.
yes,
Yeah.
Anna. So there is one.
Okay.
One of the questions is, should we always cache heavy aggregations rather than caching the final view? I think you've answered it a little bit, but
Yeah. So it depends. Actually, it really means that you really need to test it out. That's the best way to actually go about. If you feel that a view is taking a very long time to load, then it definitely makes sense to actually look at the previous step. And maybe the other option could actually be to break a view in 2 views and to cache the first part, and then to have the second part caching as well.
yeah, we have another question here, which is also what, if you make changes to a view, the schema of a view or the data merge, what happens to the cache at that point in time? Is it still there, or by changing the schema of a view or adding a new calculated column, does that
That triggers,
immediately?
yes, so that triggers a new cache. Actually, obviously, you have to create a new column in your table on the database.
Mhm.
If it's not recached, then the table won't know about the new column.
Right. Okay.
Yeah.
Great. So I think this is also good important. If there's no other questions, I'm just going to check one more time here. But would be a best practice to use the cache when something is slow or timing out, not to start using caching out of the gate. I think I can answer that. That yes, I think you should use it wisely, as Anna put it, and not using it right out of the gate. Um, but maybe something that also helps me when I am building intensive data intensive is if you have specifically on views, if you have a lot of calculated columns using case statements, like if this value is this, then do that. If this value is this, case statements are notoriously very slow. Casting of columns, if you do any kind of changing of types, those are also very, very slow as well. Um, and of course, ranking windowed functions, right? They use a
Mm.
lot of CPU, and that may waste cycles, which will cause timeouts. So if my initial view has a lot of those, I would probably go straight into caching right out of the gate. I don't know what you think about that, Anna, but
Yeah, I usually go with the first approach, which is like test it out and see how it goes. And then, yes, of course, if I know that I have used some pretty heavy formulas, then yeah, I know where to go to actually, and I have I have kind of a pre a feeling that where this is coming from, actually, where the problem is coming from. By the way, when you're on a view and there is a timeout, sometimes not very clear where the timeout is coming from. So you have that little a tick mark button at the top of the view where you can actually click on it and it will tell you which of the transformation is causing an issue. That helps with the
okay.
debugging as well.
Now, of course, one of the questions I was asked when we were thinking of doing this webinar earlier on was, why are we doing a webinar on caching when we have data flow coming out, and data flow is now scheduled to be delivered definitely before the end of the year, as soon as we can. Potentially November 30th would be our alpha release to certain customers, and more on this in just a second. But why would we be able to? Why are we covering a topic that potentially will be made, a non-topic in a few months or over the next year for sure. And the reason is because we've invested a lot of time, and our customers have invested a lot of time in building all these systems and views. And of course, the change will not happen overnight. To redraw or to redesign the entire data flows using our data flow tool will require some time. So for some time over the next months, a lot of customers will continue to use views and merges and fusions, and as such, caching continues to be a very important element. And the second reason is, even though data flows will be available, views will continue to exist for some time. Even though data flows will be able to cover fusions and merges, the concept of creating a quick view is still in our plans to support. We feel that sometimes you do not need, especially for small tables, you do not need to create a data flow to create a small calculated column. And of course, for those of you that don't know what data flows are, there's going to be a webinar on that very soon. But data flows is the next generation of building a end-to-end data flow process where you start with one or multiple input tables, and you apply calculations, you apply merges and fusions, just like you see, for example, in one of Anna's diagram previously. Whereas before you would see each object being an item on your data explorer, now it's all inside one single diagram. Where you flow from one node to the other. So one data flow will be able to put out multiple tables, one or multiple tables in one single run. And because these are tables, they are by nature already quote unquote cached because they're already physical. So there's no more virtual views. The views are used during the creation of the data flow or the execution of the data flow, but they don't exist. So the dashboards will always be hitting solid physical data stored on disk, which is of course much faster. And again, on the data flow topic, if you're interested in knowing more, shoot the support team an email, or myself an email, or Anna. And as well, we're taking requests right now for anybody that wants to be an alpha tester, not a beta tester, an alpha tester. We actually reverse things around here at Click Data. We go a bit earlier. We'll provide an alpha access to the data flow as early as November 30th. So in just about a month, will be our first quote unquote public facing version of Dataflow, and we're taking anybody that's willing to give it a test, not for production use, hence the alpha. Would love to hear if anybody's interested in testing that out. Please do send me an email directly or to Anna. And with that, if there's no other questions, Anna, thank you very much. Awesome webinar.
Thanks.
Hope I can count on you for a few more webinars next year. Awesome. Well, thank you very much, everyone, and have a great day.
Bye.